Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. It's so good to be back with you here on a Wednesday. Before we get started, I like to get to know who's in the room. So I would like for you to tell me where you're from, what test you're prepping for, and your favorite ice cream flavor. Where are you from? What test are you prepping for? And your favorite ice cream flavor. It helps me know what test you're prepping for because while the questions are solid and they're the questions that we're going to go over, it helps me kind of know what rabbit trails to take. So I'm from Central Florida. For those of you who don't know, I am a math coach in Central Florida right now. And my favorite ice cream flavor is probably anything with peanut butter and chocolate or mint chocolate chip. I do not like chocolate ice cream at all. It has to be like a vanilla base with extra stuff added to it. I do not like chocolate ice cream. So with that said, hello, your test is next weekend. Good luck. You've got this. Remind me again I know you've been here a couple of times. Remind me what test you're taking. Are you taking the FTCE middle school, high school, or elementary, or the GK? Hello, San Antonio, Texas. Welcome. And you're taking the EC6, cookies and cream. Oh, I wish I could have cookies and cream ice cream, but I am allergic to gluten, so no cookies and cream for me. So let's go ahead and get started. Like Jason said, if you have questions while we're working through problems today, please don't hesitate to ask and please let me know. Also, if there are problems that you want me to go over, please let me know. Someone actually tagged me in a post on our Facebook with a specific problem they wanted me to go over. And people have let me know in the comments different topics they want me to go over as well, which is where a lot of these problems are coming from today. Hey, I didn't know you were from Lake Mary. You're real close to me. Awesome. And you like strawberry ice cream, taking the GK math. Awesome. North Dakota. Wow, that's far away. Taking the Praxis core. First time here. Welcome, Caroline. and you like cherry vanilla briars. I have never had that. But Chris, welcome. Didn't know you were from Lake Mary. You're super close to me. All right, let's get started. I'm so excited that we have some new faces in here today. So someone tagged me in this problem on Facebook, and so we're going to start with this problem. So like I said, if you have problems that you are struggling with or topics that you're struggling with, please let me know because it helps me kind of guide our conversations. So in 81 boxing matches, Rocky has won 51 by knockout. Assuming Rocky wins all future matches by knockout, how many more matches does he need to complete for his ratio of knockouts to matches to become 2-3? So when we're dealing with ratios, we want our ratios to be equivalent. That's how we solve ratio problems. So what they've provided us is that they want to know how many more matches he needs to complete for his ratio of knockouts to matches to be 2-3. So the ratio they've given us is knockouts to matches. And so that's going to need to equal knockouts to matches. So when we're solving this, we know that they've given us a 2-3 ratio. So we want the ratio to be 2-3. And we need to know how many more does he need to complete for his ratio to be 2-3. So he's already won 51 matches. He's won 51 matches out of 81, and we're trying to figure out how many more he needs to complete to have that 2-3 ratio. So if he's won 51 out of 81, that's his current ratio. If we divide that using our calculator, just to kind of see, I'm pulling up my calculator right now. 51 divided by 81, that equals 0.629. And he needs to complete more matches to have that 2-3 ratio. So let's use our answer choices to help us. If he completes 9 more by knockout, then he would have a 60-90 ratio. Why is that? Because if he completes 9 more by knockout, I'm adding 9 to the 51, but he's also done 9 more total matches. So I'm also adding 9 to the 81 because now he's done a total of 90. If I divide 60 by 90, I get 0.6667 repeating. If I divide 2 divided by 3, I also get 0.6667 repeating. So A is already our answer. We found it. Let's go ahead and look at what those other answer choices would give us, though. If I plugged in 6, 51 plus 6 is 57. I'm going to change colors here so that we're not getting all muddled. And 81 plus 6 is 87. If I do 57 divided by 87, I get 0.6551, and it keeps going. That does not equal our ratio of 2-3, so that's not going to work. And you'll notice if I do the same thing, 51 plus 5 is 56 over 86. If I do 56 divided by 86, I get 0.651, still not going to be the correct ratio. And you're noticing that we're decreasing. So when I do 3, it's going to be even lower than that. So in this specific problem, my answer choices were actually more helpful than doing my ratio like this over here. All right, a probability problem. So Chris actually asked for us to do probability in last week's session. So I have a couple of probability problems here as well. So let's go ahead and look at this problem. And I'm going to let you know that this problem and the next problem are very similar. So we're going to really dive into this problem, and then we're going to kind of fly through the next problem. It's just a different question. So in a jar of Jolly Ranchers, there are 46 blue Jolly Ranchers, 32 yellow Jolly Ranchers, 58 red Jolly Ranchers, and 24 green Jolly Ranchers. A student pulls 3 Jolly Ranchers at random out of the jar and pulled 2 red and 1 green and eats them. Another student comes along and pulls a Jolly Rancher out of the jar. What is the probability that the Jolly Rancher is a red Jolly Rancher? It's a lot of information. So let's break it down. What did they give us in the beginning? They gave us the contents of that jar of Jolly Ranchers. So this is like the total number of Jolly Ranchers we have. Then in our story, they tell us that a student comes along and pulls some Jolly Ranchers out of the jar and eats them. Why is that significant? Because it's going to change the number of Jolly Ranchers in the jar when the second student comes along to pull Jolly Ranchers out. So we've got 3 different sections of information here. When we solve probability problems, we have our desired over our total. Probability. So when we're solving probability problems, we have our desired number on the top over our total that we have as an option. So in this case, how many total Jolly Ranchers are in our jar? Well, you would think we would add 46 plus 32 plus 58 plus 24, and you're kind of right. So let's go ahead and do that. 46 plus 32 plus 58 plus 24. And again, I'm going to use my calculator because I can. If you're taking the GK, you absolutely get a calculator. All other tests, you definitely need to check with your study companion or your blueprint or something like that to check to see if you get a calculator. So when I add all of those together, I get 160. And what is my desire? My desire is the probability that my Jolly Rancher is red. So there are 58 red Jolly Ranchers. However, that is not the right answer. Why is that not the right answer? Because of this yellow section right here. They came in and they told us, hey, you've got all these Jolly Ranchers, but someone came and pulled some Jolly Ranchers out of that jar, and then the next student came. So we don't actually have 160 Jolly Ranchers. How many Jolly Ranchers did this person pull out? 3. So we have to subtract 3 Jolly Ranchers from our total. So the problem is almost exactly the same. In a jar of Jolly Ranchers, we've got all these Jolly Ranchers. I'm not going to read that statement again because it's the exact same as this one. So in a jar of Jolly Ranchers, we've got all these Jolly Ranchers. And then a student comes along and pulls 3 Jolly Ranchers out, 2 red and 1 green, and eats them. All the same. And then another student comes along and pulls 2 Jolly Ranchers out of the jar this time. Not just 1 Jolly Rancher. They pull 2 Jolly Ranchers out of the jar. What is the probability that the first Jolly Rancher is green and the second Jolly Rancher is blue? So when we are solving problems like this, where we've got double probability, what we're really dealing with is 2 isolated probabilities, because I'm going to reach my hand in the jar and pull a Jolly Rancher out. There's my first probability. Then I'm going to do it again. It's a totally different probability because I'm reaching my hand into that jar a second time. So I have 2 separate probabilities going on. I've got my green probability and I've got my blue probability. And what I'm going to do to find my total probability is multiply those 2 probabilities together. And I'm going to change our view here because you can't see those bottom numbers. So what is the green probability? Well, we already figured out that when we add all of these numbers up, it's 160, right? Because probability is desired over total. So this is going to be out of 160. And I just realized that I did not share these notes, these PDFs with you. So I'm going to copy this and post it. This link is going to give you the ability to download these. Oh, I just lost my computer. This link is going to give you the ability to download these slides as a PDF. Okay, moving on. So my green probability is not 100 out of 160 because remember, that yellow statement told us that the student came along and pulled 3 Jolly Ranchers out. So I have 157 Jolly Ranchers left in the jar after this student pulled 3 out. How many green are left in the jar? How many green are left in the jar after this student pulls 1 out? 24 minus 1, which is 23. If you're not following me, make sure you add a comment and let me know if you're confused. Then, so student comes in, pulls the first Jolly Rancher out, and it's green. Sets it aside. How many total Jolly Ranchers are left in the jar? Not 157. Now there's only 156 Jolly Ranchers in the jar because they pulled this green one out. How many blue Jolly Ranchers are in the jar? 46. Because no one has pulled a blue Jolly Rancher out of the jar yet. So we don't have to subtract anything from that number. How do I multiply fractions? I just multiply straight across. I don't have to have common denominators or anything crazy like that. So 23 times 46 equals 1,058. 157 times 156 equals 24,492. That answer is not an option. That does not mean you did something wrong. Why is that answer not an option? Because we have to simplify it. So I'm going to divide them both by 2. Divide this by 2. Divide this by 2. So the denominator divided by 2 is 12,246. And the numerator divided by 2 is 529. So our answer is D. Does that make sense? On the test, would you reduce it? Absolutely. Absolutely. All right, let's keep going. This is a typical number sense word problem. It's just making sense of numbers. So this is great for K6 or GK, maybe a little bit of middle school, probably not, but GK or K6 or Praxis Core. On Monday, a local theme park sold 312 ice cream cones. On Tuesday, they sold half that amount. On Wednesday, they sold 5 less than 3 times what they sold on Tuesday. How many more ice cream cones did they sell on Wednesday than Monday? We've got a lot of information here. So we've got Monday. Whoop, my hand just zoomed in. We've got Monday, Tuesday, and Wednesday. And they gave us Monday, 312. And before I get started, I'm going to look at what they're asking for. They are asking for how many more did they sell on Wednesday than Monday? So I really need Wednesday and Monday. I don't need Tuesday. However, I can't find Wednesday without finding Tuesday because they say on Tuesday they sold half what they sold on Wednesday. But on Wednesday, they sold 5 less than 3 times what they sold on Tuesday. So if we don't find Tuesday, we can't find Wednesday. So let's start with Tuesday. On Tuesday, they sold half that amount. So how do I find half of 312? Divide by 2. 312 divided by 2 is 156. That was easy. But now, on Wednesday, they sold 5 less than 3 times what they sold on Tuesday. What does that even mean? Let's break those words down. 5 less than 3 times what they sold on Tuesday. Well, if I'm looking at 5 less than 3 times, don't get confused by doing 5 minus 3 times Tuesday. Because if I do that, I'm going to end up with a negative number. If I said, what is 5 less than 12? What would you tell me? What would you tell me? What is 5 less than 12? You would tell me 7. Did you do 5 minus 12? Or did you do 12 minus 5? You did 12 minus 5. 5 less than means something minus 5. So in this case, if we do 5 less than, we are going to do something minus 5. What is that something? 3 times what they sold on Tuesday. 3 times what they sold on Tuesday is going to be 3 times 156. So 3 times 156 minus 5. Let's go ahead and solve that. 3 times 156 is 468 minus 5 equals 463. So that's what they sold on Wednesday, 463. How many more did they sell on Wednesday than Monday? Subtract. 463 minus 312 is 151. You got 53.6, but you set up an equation 3x. Okay, 3x minus 5 equals 156. That is, you're not going to set it equal to 156 because Wednesday they sold 5 less than 3 times what they sold on Tuesday. So you're doing 3 times Tuesday and then subtracting by 5. It wasn't Tuesday equals 5 less than 3 times. Does that make sense? So it's 5 less than 3 times Tuesday is what you would do. That's why it's not a decimal. All right. Problem 4. How many real solutions does the equation below have? This is for my high school people, maybe middle school, depending on what test you're taking. You'd want to look at your blueprint. So how many real solutions does the equation below have? I'll answer your question in a minute. So f of x equals x squared minus 6x plus 8. So it has the potential to have 2 solutions. Why? Because it's squared. So we know that a squared equation creates a parabola. If you're taking a middle school or a high school math exam, you got to know that. So it creates a parabola. But parabolas can also float, in which they would have no real solutions. Parabolas can bounce, in which it would have 1 real solution. And parabolas can cross the axis, in which it would have 2 real solutions. So how do I figure out how many real solutions it has? Real just being any sort of number that exists. In this case, it would have no real solutions because it's not actually crossing the x-axis. Well, if we're familiar with quadratics, then we know that we can use the quadratic equation to factor if we really wanted to. The quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a mouthful, where this is a, this is b, and this is c, only the coefficients. If I use just this part of the equation, which is called the discriminant, I don't know if I spelled that right, so we're just going to erase that. That's called the discriminant. If we use the discriminant, we can figure out how many real solutions it has. I'm going to do it and then work backwards. So b squared minus 4ac. b is negative 6, so negative 6 squared minus 4 times a, because there's an imaginary 1 there, times c. Negative 6 times negative 6 is positive 36. Negative 4 times 1 is negative 4, and negative 4 times 8 is negative 32. 36 minus 32 equals 4. Now, because I got a positive real number, I'm going to have 2 real solutions. Here's why. Can I take the square root of 4? I can. So I'm going to have 2 real rational solutions, actually. I'm actually going to have 2 real rational solutions. Sometimes they might throw that word in there too. If I got the number 0 for my discriminant, what would that mean? That would mean I only have 1 real solution. Because what would end up happening, going back to this equation, is I would have negative b plus the square root of 0, which is 0, divided by 2a. And I would have negative b minus the square root of 0, which is 0. So it would create the same exact answer. If I get a positive number, whether it's 4 or 5 or 6 or 7, it doesn't matter. I'm going to get 2 real solutions. Now, if this equaled 5, I would have 2 real solutions still, because it would still cross the x-axis twice. Because I could do the square root of 5. It would just be really, really messy. But I could have a positive and a negative version of it. I just would have 2 real irrational solutions, not 2 real rational solutions. If I got a negative number, what would that mean? Like if I got a negative number for this value, what would that mean? That would mean I would have no real solutions, because we cannot take the square root of a negative number. Because we can't take the square root of a negative number, it would be no real solutions. The square root of a negative number would create a floating parabola like this. But in this situation, we have 2 real solutions. Now, I have a question on when would it equal 156? So that's a great question. It would have to say something like on Wednesday. I'm trying to think of how it would be worded. On Wednesday, they sold 5 less than 3 times what? No, that wouldn't work. I'll get back to you on that. The wording would be, I don't know if in this case that would be an example. I will find one where you would set it equal. And I will find me on Facebook and message me, because I'd have to really play with that. And I know you take your test this weekend. Otherwise, I would throw it into next week's thing. But I want to make sure I answer that question. So find me on Facebook, Amy Sink, and I will message you. I'll find an example and message you, because you've put me on the spot and now I can't think of an example of how that would be worded in this exact problem. So let me think about that. And like I said, message me on Facebook and I will answer you. And then I'll bring that answer back to everybody next week. But I know you take your test next or this weekend. So I just want to make sure you get an answer. All right. Which of the following shapes? Oh, perfect. But you can still find me on Facebook, so it reminds me. Which of the following shapes has equal angles? Parallelogram, rhombus, rectangle, or trapezoid? Which of the following shapes has equal angles? Okay, so we got to know our quadrilaterals. Everybody needs to know their quadrilaterals. K6, pre-K through 3, GK, Praxis, Core. You guys have to know it because they will ask you to classify these. Middle school and high school, you guys have to know it because they're going to have you, they will have you applying what you know about quadrilaterals to solving pieces of the quadrilateral. So everybody needs to know their properties. So equal angles. In fact, this should say has to have equal angles, because a parallelogram could have equal angles, but it doesn't have to have equal angles. So a parallelogram, by definition, has 4 sides, and it has 2 pairs of congruent parallel sides. So a rectangle is technically a parallelogram because a rectangle has 4 sides and it has 2 pairs of congruent parallel sides. These 2 are the same and these 2 are the same. But a parallelogram could also look something like this. And those angles are not going to be equal. This is an acute angle. This is an obtuse angle. So a parallelogram is out. A rhombus has 4 sides. It has 2 pairs of congruent parallel sides. And in fact, it has 4 equal sides. So if I draw a rhombus, it could look like a square, but it could also look like this. Because a square has 4 equal sides and has 2 pairs of congruent parallel sides, but so does this. The thing that sets this shape apart from this shape is that this shape has 4 equal angles. It has those 90-degree angles. And a rhombus that's not a square does not have that. What makes a rectangle a rectangle? A rectangle has 4 sides, 2 pairs of congruent parallel sides, and it has 90-degree angles. And therefore, the rectangle in this case is the only one that has to have equal angles. That's why it should say has to have and doesn't just say has, because the parallelogram, the rhombus, have the potential to have it, but they don't have to have it by definition. All righty. What is the area of the shaded portion of the square below if each of the unshaded areas is a quarter of a circle? This is an interesting question. So it combines our knowledge of area of a circle and area of a square. I want you to think about this. If this is a square, we know we're doing area equals length times width. They've also told us, and this has a star next to it because someone asked me to do, last week someone asked me to do a area problem that involved circles, and I can't remember who it was. So if that was you, just give me a shout out. Say, hey, that was me. I can't remember who it was. We also have area of a circle. Area of a circle is pi r squared. If they don't define pi for you, you can use pi as 3.14. Oh, I apologize. That's my Great Dane barking. So if we're going to solve this problem, we need to find the area of the whole square. And then we need to subtract these quarter circles out of the square, which is going to leave us that shaded area. Yes, I'm so glad you're here. I was hoping you were going to be here for this problem. Okay, let's keep going. So area of a square, and then we're going to subtract our circle pieces. So area of a square is length times width. Well, if it's a square, then all the sides are the same. So this side is going to be equal to this side. So I know it's going to be 18 times 18. I'm going to pull out my handy dandy calculator. 18 times 18 equals 324. 324 feet squared. I'm not done because that is the area of the square. I need to get rid of all of those little quarter circles. Now, I want you to think about this. What am I going to subtract? I'm going to subtract a whole circle. Why? Because I have 4 quarters. So if I look at what a circle looks like, I've got all 4 pieces. So I can just subtract an entire circle. I don't have to divide that. So my area of my circle is pi r squared. What is the radius going to be of my circle, though? The radius is going to be 9, not 18. If we think about a circle, the radius goes from the center to the outside. So really, this would be the center. The vertices of these pieces would be the center. And then the outside of the circle is drawn here. So this is my radius. So I'm going to take 18 and cut it in half, and it would create 9 squared. So 81 times pi, 3.14. Handy dandy calculator. 254.34. Now I just need to take my square, subtract those circles, and I've got my answer. 324 minus 254.34 equals 69.66. Now, here's what I want you to think about. I'm going to copy this problem and paste it because I want to show you a variation of this problem. Okay, erase that, erase all of that, and erase all of that. Okay, now, what if the problem looked like this? What if the problem looked like this? Whoop, that's way too big. What if they asked us to find the area of the shaded portion here, and it looked like that? And they told us that this was 9. What would you do? In this case, we would find the area of that rectangle. So we would do 18 times 9 instead. That would give us 162. And then we would find the area of our circle, but then we would divide it by 2 because this and this would only create a half of a circle. So we would only be subtracting a half of a circle. Does that make sense? I wanted to show that to you because I just wanted you to be able to see how to manipulate a problem like this. Tulip Lover, I don't know what your real name is, I'm sorry. Would problem 4 be on the GK? Let me see. If this is the problem you're referencing, I'm trying to think of what your blueprint looks like. Most likely not, but I'm going to check that for you before we're done. So I'm actually going to pull up that blueprint for you. GK Math blueprint, and I will check that before we're done, and I'll let you know. I don't think so, but I don't want to misspeak. All right, let's go on to the next problem. I have one more circle problem for you because I actually really like circle area problems. A basketball court is being repainted. The entire court has been repainted with the exception of the 2 keys, with dimensions shown below. If paint costs $1.50 per square foot, what will it cost to paint the keys? Okay, so the keys are just those shapes that are at the, where like under the goal where people can shoot like free throws, like the free throw line would be here. So that's what your key is. And they've already repainted the whole thing, but they haven't repainted the keys yet. And they want to know what it's going to cost to paint the 2 keys. Let's come up with a plan together. Number 1, what do I need to find? I need to find the area of a key. Then what do I need to do? Then I need to multiply that number by 2. Why do I need to multiply by 2? Well, because on a basketball court, there's 2 keys. Then what do I need to do? Then I need to multiply by $1.50. Why? Because that's going to be the cost of the paint per square foot. So when we look at this and we're going to solve it, we've got a rectangle and we've got a circle. So I'm going to find the area of my rectangle and I'm going to add that to the area of a half circle. Well, area of a rectangle equals length times width. So that's going to be 19 times 16, which equals 304. How do I find area of a circle? Pi r squared. What is my radius going to be for this circle or this half circle? The area of a circle or the radius of that circle is going to be 8 because this whole thing is 16. So this piece right here is going to be 8. So pi times 8 squared. So 64 times 3.14 equals 200.96. Now I'm going to add those two numbers together, which is going to give me the area of this key. So 304 plus 200.96 equals 504.96. That's the area of one key. But we just decided that there's two of them. So I'm going to multiply that times 2. And that's going to give me 1009.92. That's the area of both keys. Now I'm going to multiply that times $1.50. And that's going to give me $1,514.88. Now, you asked, what's a key on a basketball court? You're not dumb. To be quite frank, I didn't know what it was either. However, you really don't need to know because they're not going to expect you to know that. They gave you the shape and they told you that there's two of them. So in all reality, you don't need to know what the key is because they gave you the shape and they said that you have two of them. Now, on a basketball court, it has that key like this, and then the key like this, and the hoop is here, and the hoop is here. And then your half court line is here. So the key is just that part that, the part that like is where the free throw line is, and it's right under the basket. All right, problem number 7, done. Problem number 8, simplify. 8 times 5 minus 3 times 3 squared times 4 divided by 1/2 plus 9. All right. This is just an order of operations problem, but it's a tricky one. So I want you to follow me. Oh my goodness. I am so glad you just caught me on my error right there. Someone just told me, don't we divide the area of the circle in half? Yes, that is not the correct answer. Let's go back to this. This is why you need to check your work. This is not a whole circle. You are amazing, Yahira. I hope I said that right. This is not a whole circle. It's a half of a circle. So I have to take the area of this circle and divide it by 2. Goodness gracious. So all of this is not correct. So I'm going to, and you know what? Did you see that that answer was right there? You did. And so it's so easy because they know that that's going to be an error that people are going to make. So we have to take the area of this circle and divide it by 2 because there's only a half circle in each key, not a whole circle. So that actually means we have 100.48, which means we have not 500, we have 404.48 times 2, which is 808.96. And then we multiply that times $1.50. and that gives us $1,213.44. If I had a golden star sticker, I'd be giving it to you right now because you just caught my error. Thank you so much. High five. All right, now we can do our order of operations problem. We all make mistakes. 8 times 5 minus 3 times 3 squared times 4 divided by 1/2 plus 9. All right, order of operations is PEMDAS. But what I need you to realize is parentheses and exponents are kind of partnered together. Multiplication and division are kind of partnered together. And addition and subtraction are kind of partnered together. What that means is I'm going to do parentheses and exponents first. Then when I'm done with that, I'm going to move to multiplication and division. But multiplication does not have to come before a division. Division or multiplication can come first. I need to solve it in the order it shows up in the problem from left to right. Then when I'm done with that, then I'm going to move on to addition and subtraction. But again, it operates the same way. So I'm going to look for parentheses and exponents first. So I'm going to solve this section right here and keep everything else the same. So 8 times 5 minus 3 parentheses. 3 squared is 9 times 4 divided by 1/2 plus 9. I'm going to continue solving those parentheses. 8 times 5 minus 3 times 36 divided by 1/2 plus 9. Check. That section is done. Now I'm going to do multiplication and division. Again, I'm going to do it in the order it shows up in the problem, and I'm going to do it one step at a time. So I'm going to solve 8 times 5 first, because that's the first multiplication I see in this problem. 8 times 5 is 40. I'm going to keep everything else in my problem the same, so I don't miss any steps. This is just how I solve it. Some people can do multiple steps at a time. I cannot. What is the next piece of multiplication that we see? -3 times 36. I am not going to do 40 minus 3 because I'm not done with my multiplication and division yet. So -3 times 36, I'm going to use my calculator, is -108. So 40 minus 108 divided by 1/2 plus 9. What am I going to do next? I'm going to do my division. However, when we divide fractions, we have to keep change flip. So this is not 108 divided by 2. This is -108 divided by 1/2. And because that's a fraction, I'm going to keep change flip. So keep the number, change the symbol, flip the fraction. So 108 times 2 . Sorry, my dad's trying to open the back door and he doesn't know how to use it. Push the top piece up and the bottom piece down. Use the, up and then down. 108 times 2 is -216. It's a circus over here today. We've got the dog barking, my dad trying to let the dog, it's a whole circus. So we have 40 minus 216 because the 216 replaced this entire highlighted area plus 9. 40 minus 216 is -176 plus 9 gives us -167. Excellent job, Chris. Does that make sense? All right, we have time for one more problem. And to answer my friend Tulip Lover's question, would problem number 4 be on the FTCE GK? On that blueprint, it specifically says, solve equations and inequalities, example, linear or quadratic, graphically or algebraically. So that leaves the interpretation, because that's a quadratic, and we were solving it algebraically, that you could have the potential to see that on the exam. All right. Last problem, and then we'll be done for today. And if you are still with us at the end, Dr. A, thank you for telling me your name. You're welcome, Angel. All right. So last problem, and then Dr. A has a special code for those of you who are still here if you're interested in our boot camps. A gym offers 2 monthly plans. Plan A costs $10 per month after an initial $99 fee. Plan B costs $22 up. This should say per month, not per minute. Per month after an initial fee of $15. What is the cost of the 2 plans in dollars when they are the same price? So in this situation, we're going to set up an equation. So when I think about this, I'm thinking $10 per month. So if it's 1 month, it's $10. If it's 2 months, it's $20. If it's 3 months, it's $30. So $10 per month, I could say that M equals months. So 10 times M, after an initial $99 fee, I'm going to add $99 to that. And that $99 is just $99. So 10 times M plus 99. This kind of looks like slope-intercept form. Y equals mx plus b. And then plan B is going to cost $22 per month. When you see a per, you're likely multiplying it by something in a word problem after a $15 fee. And what do they want to know? The cost when they are the same. What does same mean? Equal. So if I set them equal to each other and solve for M, then I can find when they're equal. I'm going to subtract 22M from both sides. If you subtract 10M from both sides, you'll still get the same answer as long as you do the same thing to one side as you do to the other. I get negative 12. Yes, negative 12M plus 99 equals 15. Subtract 15 minus 99 because I'm going to subtract 99 from both sides. And I get negative 12M equals negative 84. Divide both sides by negative 12, and I get M equals 7. That is not the answer, though. That is the number of months. They want to know the cost of the plans when they are the same. So it's going to happen at that 7th month, but then I need to take that and plug it into either equation. It doesn't matter because they're going to be the same at that point. So I'm going to do it times 10 because I just like the number 10 better than the number 22. 10 times 7 is 70 plus 99. So that's going to equal $169. All right. Does anybody have any questions before we wrap up tonight? Can we get a derivative question next week? Absolutely. Do you have a preference in what kind of derivative? Otherwise, I'll do a couple derivative. I'll do like 2 derivative problems so that we can do a couple different kinds. But I will absolutely do a derivative problem next week. You got 7, but you subtracted the 99 from the 15 first. It shouldn't matter if you subtract the 99 from the 15 first. You got 7 as your answer when you solved the equation, or you got 7 as your months. I'm not sure what you're saying, but it shouldn't matter. Like, I'll solve that. I like that you asked that question. If I do 10M plus 99 equals 22M plus 15, and I subtract the 99 from the 15 first, it doesn't matter because then you get 10M equals 22M minus 84, and then you subtract the 22M and you'll still get negative 12M equals negative 84. So it doesn't matter what order you do that in. All right, I'm going to turn it back over to Dr. A. If there's anything else that you want me to go over next week, please leave it in the comments, and I will see you all next week. Thank you guys so much for joining us.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.